Welcome back to Pre-Algebra with Miss Betsy. Today we are going to have a very brief video that talks about prime numbers and composite numbers. If you happen to be using the first edition of Pre-Algebra for Christian Schools by Bob Jones University Press, this corresponds to section 5.3 on page 151 of the text. If you're not, it doesn't matter because prime composite numbers are the same no matter where they occur in your particular text. Before we get started though, I would like to know the answer to this. A young man has two coins. Together they total 6 cents. One of them is not a nickel. So what are those two coins that he's using? Yes, they are American coins. Well, they are a nickel and a penny. Yes, I did say one of them was not a nickel. I did not, however, say that the other one was not a nickel. So, what are prime numbers? This is more vocabulary. Remember, I've said from the beginning, there's an amazing amount of vocabulary in the study of the whole mathematical world. If you don't know what your terms are, you cannot do the problems. You have to know the definitions. Prime numbers are any whole number, that means it's not fractional, any whole number greater than 1 that has exactly two factors. Those two factors are the number itself and the number 1. Exactly two factors. No other factors possible. So, if we have the number 1, could we be talking about number 1? Is that prime because it has 1 times 1? Well, no. Because it says that a prime number has to be any whole number greater than 1 that has exactly two factors. They should actually put two unique factors in here because one of those factors can be 1. The other has to be the number itself. So 2 then would be a prime number because the only two numbers that you can multiply together and end up with a product of 2 would be 1 times 2 is 2. Can you say 2 times 1? Well, yes, because multiplication is commutative. Doesn't matter what order those factors are in, but you still are only using two separate numbers to multiply together. It's 1 times 2. 1 and 2 are the only two factors. 4, on the other hand, is not a prime number. Because how can you arrive at 4? Well, you can say, of course, that 1 times 4 is equal to 4, which fits our first part of our definition here. It says the number itself and 1. This is the number itself and 1. When we multiply those together, we do get 4. However, it says that there are exactly two factors. And there's one more way that you can arrive at a product of 4. And that, of course, is by saying 2 times 2 is equal to 4. So how many what's the total number of factors that are involved in 4? Well, 4 has 3 possible unique factors. 1, 2, and 4. You can pair together 1 and 4. Or you can use 2 as a factor twice. So 4 is not a prime number. That's the second half of our definition, second half of our tape for today, is if it's not a prime number, we've got all of these numbers. There are far more numbers out there that are not prime than are specifically prime. So what do they call those? Well, they call those composite numbers. And composite numbers are any number that's not prime. Composite and prime. And then you do have to remember that you have the number 0 and you have the number 1. And they are neither prime nor composite. They are just 0 and 1. Remember we just talked about all of these divisibility rules? It's easy to memorize the first set of prime numbers, and that's something that I'm going to highly encourage you to do. You memorize the first grouping of prime numbers beginning with 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Having those first grouping of prime numbers memorized will help you a lot when you're factoring numbers, which we're getting into doing in the next section. Now, do you notice anything about this? 2 is even, and then we have every other number that's prime after that. They're all odd numbers. Now, why is that? Well, remember our divisibility rules. It tells us that a number is divisible by 2 if it's an even number. So the only even prime number you have is 2, because you can only multiply only 2 factors there. 1 times 2 is equal to 2. Any other even number, for example 22. Even 22 is not prime, because of course you can say 1 times 22 is 22, but you can also say 2 times 11 is 22. So 22 has 4 factors. 1, 2, 11, and 22. What they're going to be asking you in your homework here primarily is give the list, give the grouping of all of the factors that you have for the number, and then tell me if a number is composite or if a number is prime. Well, let's pick a number that I know is not a prime number. And we have 57. And you think, I can't think of anything right now. There's not a multiplication fact that you take just 2 digits together and you multiply and you end up with 57. At least not one that I can think of off the top of my head. But this number is not prime because I'm using my divisibility rule for 3's. What's that divisibility rule tell us? That's the sum of the digits rule, remember? We add the 5 and the 7 together, and we get 12. 5 plus 7 is 12, and we said that if you could divide the sum of the digits evenly, by what? By 3 or by 9, then you can divide that entire number by 9. So you can divide 57 by 3. Let's see what we get. 57 divided by 3. We bring down the 7. And we have 27 is divisible by 3. 3 times 19 is 57. So there are very few factors that are involved in 57, but there's that one extra pair that makes it not prime. 3 times 19. And you'll notice that both of these factors here are prime factors. And what we're working to is breaking each number that we have down into a combination of factors that are only prime numbers. All I want you to do in this section is learn to tell me if a number is composite or if a number is prime. Remember that when a number is prime, only has 2 factors. Those 2 factors are the number 1 and the number itself. 0 and 1 are considered neither composite nor prime. All of the other numbers are what they consider composite. And that's honestly all there is to this section. So enjoy it, and I'll see you again soon.